It is a well-known fact that Python is a multi-paradigm programming language, which means like it has multiple programming approach. One of the most popular programming approach is object-oriented programming. So in this video, we are going to teach you about OOPS and how it is going to implement in Python. Guys, moving ahead, kindly subscribe Intellipaat YouTube channel so that you guys will not miss out any of our upcoming videos. Let's go ahead with agenda of this video. In starting of this video, we are going to teach you about OOPS with some real world example. Once you are well acquainted with OOPS, we are going to teach you about classes and object in Python. You will be learning about inheritance also. What is inheritance, what are different type of inheritance, and some real-time world example. Later, you are going to learn about the difference between overriding and overloading. At the end of the video, we are going to give you some concept about encapsulation and polymorphism in Python. Guys, at the end of the video, we are conducting a quiz also to recap the concept which you learn in the video. In order to evaluate yourself, kindly put your answer in comment box and later verify it. Guys, if you want to be a Python developer engineer, in that case, Intellipaat is giving an end-to-end training on Python. For more information, kindly go through the link in description. Guys, let's go ahead with the session now.
One of the popular approach to solve a programming problem is by creating the object, and this approach is known as object-oriented programming. Okay, if you talk about the object, it has mainly two characteristics: attributes and behavior. For example, there's a parrot on our screen, right? You might be wondering what a parrot is doing over here. So this parrot is an object of class bird, which has some attribute like name, age, and color, and its behavior are that it can sing, it can dance, right? So the concept of OOP in Python mainly focuses on creating reusable code. The concept is also known as DRY, dry, that is, don't repeat yourself. For example, you can just create a function once and you can reuse the function again and again, okay? So this will prevent you from writing the same codes again and again, okay? Let's move ahead. In Python, the concept of OOP follows some basic principles such as classes, object, inheritance, encapsulation, polymorphism, okay? Let me just take an analogy and explain them one by one. Let's understand it with a real life example. That would make things easier for you to understand. So let's take human being for example. So every human being is classified as male and female. Both have a common body part such as heart, nose, hand, legs, right? If you talk about common function, they can talk, both can hear, right? They can walk, or they can even see, right? Now let's bring in the concept of OOPS over here. So here human being is a class and the common body features and functions are different class attributes. Both the male and female are inherited from the class human being. Okay, so you can say that human being is a parent class and male and female are its child class. Okay. Now every male and female would have some name and age associated to them. Right. So defining the name and age is same as defining their object. Object as something which has some physical existence in the world, as the existence of Victor at the age of 24. Correct? On the other hand, class is just a logical definition which just tells that Victor belongs to a category of male. Let's move ahead. Next concept is of encapsulation. Now both our male and female can walk, see, or listen. Right? But how do they do it is actually hidden. That is, the part of how they walk or how they see or how they listen is hidden from the world, right? So this concept is of encapsulation. Encapsulation is nothing but binding of data or code into a single unit known as class. In real time, it is generally used for security purpose. It just shows you what you actually want to see. It hides the background detail of it, okay?
A quick info guys. In case if you want to become a Python developer engineer, then in that case you can check our Python certification course. Intellipaat is giving a end-to-end training on Python. For more information on this course, kindly go through the link in the description. Let's go ahead with the session now.
Next concept is of polymorphism. Now let's take a girl named Alice. She can be a woman, She can be a wife or a mother, or she can be a daughter to her father, or if she is in teaching profession, then she can be a teacher, right? So one person with multiple roles. So you can compare this with polymorphism. So what is polymorphism? If you break down the word, poly stands for many and morph is the ability to change. So polymorphism is the ability to exist in multiple forms. Well, these examples were just to give you a brief idea of the concept. Don't worry, we are going to take multiple examples from real life to explain you the exact concept. Let's start with what are classes and objects. So what are classes and objects? Class is a blueprint for an object and objects are created from the blueprint or the class. For example, on your screen you can see an actual blueprint of the house, right? Now this same blueprint can be used to create 3 different houses with 3 different interior and 3 different family living in each of them, right? So you can consider object as the basic unit of object-oriented programming. It represents one of the particular instances of a class. Just as from a single blueprint you can create multiple houses, in the same way, just from one class you can have multiple instances of an object. Now, as each house was different in terms of its interior and family, in a similar way, each instance of an object can hold its own relevant data. And finally, all the different houses with different interior and family groups together to form a class. In a similar way, multiple objects with similar properties and methods are grouped together to form a class. And finally, objects with similar properties and methods are grouped together to form a class. In the same way as different houses with different interior and family are grouped together to form a same blueprint, right? Now let me just show you how you can define your object and class in Python. So how to create a class in Python? So syntax is class space name of the class and inside that series of statement. Let me just launch the Jupyter notebook. So there's my Jupyter notebook. I'll select Python 3 from it. Let's define our first class. So its syntax was the keyword class followed by the name of the class. So the name of the class, I'll take it as class name and then followed by colon. Remember, don't miss this colon over here. Okay. If you miss it, you'll get an error. And then with proper indentation, inside that, I'll define some variables and functions in it. Like I'll define a variable as var equal. This is a class variable. And one more thing, I'll define a function over here, like define a function as func. This function will print something for me, like I am inside the class. So this is how you create a class. So once my class is created, my next task would be to create its object. Creating an object, what I'll do, I'll just write the name of the object. Suppose the name of the object I'll choose as obj1. So obj1 equal, I'll write exact name of the class. What is my class name? Is class name itself, right? And followed by parentheses and hit enter. That's it. Even my object is created. So my next task would be, how can I access the variable and the function from inside the class, from the class, right? So for that, what I'll do, I'll just use a dot operator over here, like obj1 dot, since the object of class name is already created, so obj1 dot var. That's it. This is a class variable. So next, what I want to do, I want to access function from my class. How will I do that? Just obj1 dot name of the function, func. Execute it. Okay, we are getting an error like function takes 0 positional argument but 1 was given. Well, you can just resolve it by adding self as a parameter over here. Since it is a class method, it's not a function. Okay, it's a method. This func is a method. Okay, execute it, create our object, and then again let's call this. Okay, error is resolved. I am inside the class. Fine. So this is how you create an object and a class in Python. Okay. Now what if I want to update my class attributes? How will I do that? Let me just show you. Let's create another object as ob2 equal again class name. As we can have multiple instances of a class, I can have ob2 as another object of same class name. Okay. There's my another object. Now I'll update the var for it. So in this ob2 dot var equal, this is the updated one. Okay, now let's print both our object and see whether it's updated or not. So print obj1.var, and in a new line print ob2.var. Executed. Okay, so we got the output as this is a class variable. It was the actual one. Yeah, it was a class variable. And the next ob2.var, where we updated our variable to this is the updated one. So we got the output. Fine, let's move back to our PPT. So we already discussed how you can create a class in Python. Next, we discuss about how to create an object in Python. You know the syntax, right? Object name equal name of the class followed by parentheses. We also saw an example. And here obj1 is an object of class name. Next, we also saw how we can access the class member, right? In the example where we created two different objects like obj1 and obj2. And we also saw how we can update the class variable or how we can create a new instance attribute for obj2, right? And we also compared the output of obj1 and obj2. Okay, so next we have is the init method in Python. Well, you can consider the init method as a constructor in Python. It is a special method in Python class which is used to initialize all the variables in the constructor is used to do the same task, right? So it's like whenever init method is called, the object of a class is constructed. Fine. Let's see an example in our Jupyter notebook. Let's define a class as student. Okay. Now this class would have a init method in it. Just to tell you, this init method is followed by double underscore at the beginning and in the end. So let's define a class as student. Okay, this is our class. Inside that, we'll define our init method. Just a matter of fact, init method is followed by double underscore and it also ends by double underscore. Why? I'll tell you later in this session. Okay, so init, inside that first parameter would be self. Next, I want the name, I want the branch of the student and the year he passed out. So year. Then what I'll do, I'll initialize all my variables like self.name. For name I'm using n, so self.n equal name. Self.branch, for branch I'll be using b equal branch. This branch is same as whatever you pass in the function, that would be automatically assigned to the variable self.b. Okay, next self dot for year y equal year. Alright, so my init function is defined. Next I need to print them, so I'll define my print function over here, like define print underscore function. And so next what I'll do, I'll define my print method over here, so def space print method. Inside this I have to pass self over here, right? Since it's not a function, it's a method. Okay, now let's print some name, branch and year. So print name of the student is what? It's self.n, right? Whatever you initialize the variable with, it will be that. Print branch, that branch equal self.b, and print year, and that year equals to self.y, right? So this class is now created. Okay, execute it, check if it has some error or not. No, it has no error. Now let's create an object for our class student. So I'll write obj1 equals student. So normally this is how we define our object, right? But in this case, since we are using an init method or we are using a constructor, so we have to initialize all the variables. That is, we have to initialize self.n, self.b and self.y. Okay, so we'll pass some parameters in it. So we have to pass three parameters. The name would be, let's take Paul. His branch, let's take it CSE, that is Computer Science Engineering. And his year of passing, let's say that he'll pass this year, so it's 2019. Okay, now our object is created, so I can access the different methods from that. So I'll access the print method from our class student. So for that I'll write obj1 dot print underscore method. That's it, it's executed. So we got the output as name Paul, his branch CSE, and the year is 2019. Okay, now let's jump back to our PPT and see what we have next. Example, we just saw this example, right? How you created the student and how you define the init function in that. So now you know how to define a constructor method in Python and how to initialize its variable, right? Move on ahead.
A quick info guys, in case if you want to become a Python developer engineer, then in that case you can check our Python certification course. Intellipaat is giving a end-to-end training on Python. For more information on this course, kindly go through the link in the description. Let's go ahead with the session now.
So there's a test time and your task would be to complete this code. Okay, the question says create two new vehicles called car1 and car2. Set car1 to a red convertible worth $70,000 and with the name of FER or Ferrari. Okay, and car2 to be a blue van named Jump worth $15,000. Now your task would be to create two new vehicles called car1 and car2. Set car1 to be a red convertible worth $70,000 with the name of Ferrari and car2 to be a blue van named Jeep worth $15,000. Go through this example and try it right away. Okay, alright. So I hope the solution is ready with you guys. Just verify it. So your code goes here. What do you have? Create two new vehicles as car1 and car2. So here they want us to create two objects. Car1, it belongs to class vehicle, and another object as car2 that also belongs to the class vehicle. Next, set car1 to be red convertible worth $70,000. So what all class attributes we have up here is name of the vehicle, kind, it's a car, color, value. So first we'll change it like, let's change the name of the car. Like car1 dot name is what? Car1 name is Ferrari. Next we have that it's a red convertible. So car1 dot kind. What kind of vehicle it is? It's a red convertible. And what else we have? It's worth. So car1 dot value is how much? $70,000. Sorry, kind is just convertible and its color is red, right? So car1 dot color equal red. Okay, name is done, kind is done, color is done, and its value is done. Now we need to define all these for our next vehicle, that is car2. Our car2 is a blue van named Jeep worth $15,000. Let's see, blue van named Jeep. What kind? It's a van. Color blue, and its value is $15,000. Alright, and now let's print it. Let's see what's the output. We got an error over here. Okay, this indentation issue. Okay, are you getting the error? I have defined over here like string. Okay, and it's a float type, so I cannot have a string over here. It will be like 70,000.0, and again this will be a type float 15,000.0. Now all my errors are resolved. So as you can see, we got the output as Jeep is a blue van worth $15,000. Oops, another mistake. So we got the output as Ferrari is a red convertible worth $70,000 and Jeep is a blue van worth $15,000. So most of you who have done this must be facing these kinds of error in your code, right? So I have tried to cover all different types of error which you can face over here. Let's go back to our PPT. Let's move ahead and see what we have next. So I hope you have done your test well. So our next topic is inheritance in Python. So what exactly is this inheritance? Well, inheritance refers to the property of one class acquiring the property of other class. For example, you have inherited qualities from your parents, right? Even in the family tree chart over here, you can see that traits such as hair color and poor eyesight are passed from generation to generation. Okay, so this is what our inheritance is. Let's move ahead. So next we have is what all different types of inheritance are available in Python? So we have single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. Let's discuss them one by one. So starting on number one, we have is single inheritance. Well, single inheritance is a type of inheritance in which single class get inherited from a class. It's like your child class is inherited from the parent class. Fine. How do we do that in case of Python? Let's see. Suppose we have a class over here as fruit. We define an init function in it, and we define another class which inherits the property of the fruit class. So here citrus, it's a child class, and fruit, it's a parent class. So citrus will basically acquire all the properties of the fruit class. Let me just clarify it more with the Jupyter notebook. Okay, so let's define a class as fruit, class fruit. Inside that we have defined our init function, self, and what it says print I am the parent class. Okay, next what we'll do, we'll define another class like class citrus. Citrus is a type of fruit, right? So next what we'll do, we'll create a class as citrus. The fruits are only citrus, right? So it has to acquire all the properties of the fruit class. Okay, so again inside this I will define a init function, self. Here we will be using a super method over here, super double underscore init. Okay, why we are using super function? Super function is used to call methods or variables from the parent class. Okay, so super init means that I'm calling this particular init function. Okay, let's move ahead. Next, inside this what I'll write, print citrus, I belong to fruit class. Okay, now two of our class are created, and the class citrus is inheriting all the properties of the class fruit. So it's a single inheritance. Okay, let me just show you by creating an object of it. Let's create an object obj1 equal citrus. Okay, call it, execute it. Let's see what's the result. Sorry, I have missed a dot operator over here. Alright, so as you can see, we got the output as I am the parent class. How? From here, super.init. Alright, it has acquired all the properties from its parent class, that is fruit, and citrus has a print statement in it, like I'm a citrus and I belong to the fruit class. Alright, so this was about single inheritance. Let's move ahead. Next is multiple inheritance, that is one class inherit from multiple class. For example, you can see here you have two different classes like class A and class B. So class C will acquire the property of class A as well as of class B. So let's see an example. Multiple inheritance, we have class A, class B, and class C. Okay, so here it's just confirming that class C has acquired the properties of both A and B. So our result is subclass C comma A, and is subclass C comma B will just give the output as true or false. The statement is subclass C comma A tells that whether the class C it's a subclass of A or not. So the result would be in true or false. And again, is subclass C comma B will tell whether C is a subclass of B or not. Okay, if both the results are true, we'll get the output as true. Let's see what output do we get. So let's define a class A. We don't want to do anything in it, pass it. Again, class B, pass it. Class C, but C will inherit property of class A as well as class B. Even as this. If we don't want anything inside the class, then what we write is pass. Next, what we'll do, we have a function as is subclass. Is C a subclass of A? Let's see. Yeah, it is. And is subclass, is C a subclass of B? So both are true, right? So I think we should get the output as true. Let's see. Yeah, so we got the output as true. So there's nothing but an example of multiple inheritance. Okay.
A quick info guys, in case if you want to become a Python developer engineer, then in that case you can check our Python certification course. Intellipaat is giving a end-to-end training on Python. For more information on this course, kindly go through the link in the description. Let's go ahead with the session now.
So next type of inheritance that we have is multi-level inheritance. It's like one class inherits from other and which in turn inherits from other. It's like your grandparent, your parent and you. Okay. It's like your parents have acquired properties from your grandparent and you acquire properties from your parents, right? But indirectly you have acquired properties from your grandparent as well. Okay. So there's a multi-level inheritance. Let's see an example. So as a part of example, we have class A. Inside class A, we are writing x equal 1. Then B is inheriting A. So that means even B has x equal 1. So next, class C, it is inheriting the property of B. Okay. So we can say that class C has x equal 1. Let's see whether it's true or not. Class A. Inside this, I'm defining a variable as x equal 1. Next, I have is class B. I don't want to do anything, but this B will inherit the property of A, and we have class C, which will inherit the property of B, not of A. Okay. Pass. So how will we verify whether it's a multi-level inheritance or not? If you're creating an object of class C and you're getting the output as 1, then definitely it has indirectly acquired the properties of class A. First we need to create an object. So obj1 equal object of class C. So C parentheses, and now let's try to access X. So obj1 dot X. What do you think? Let's see. Okay, we got the output as 1. It means C has indirectly acquired the properties of A. So it's an example of multi-level inheritance. Let's move ahead. Next we have is the hierarchical inheritance. Well, hierarchical inheritance is the one in which more than one class inherit from a class. It's like there's a parent class A and the class A has 3 different child class B, class C and class 3. All 3 classes are acquiring the same property from class A. It's like saying your parent have 3 child, okay? You, your brother and your sister. Alright, let's see an example. Hierarchical inheritance. So we have class A, B is inheriting the property of class. Okay, so we have class A, class B is inheriting property of class A, and again class C is also inheriting the property of class A. Okay, then again we are checking if B is a subclass of A or not, and C is a subclass of A. Let's see what's the output. So we have class A. Same example you can take like x equal 1. Okay. Then class B, it's inheriting the property of class A, right? Pass it. Again class C, it's again inheriting the property of class A, not B but A. Alright, again pass. Again I create another object of class C. So obj1 equal C and obj1 dot x. So it should give me the output as 1. Another way to verify it is subclass B and A. B is a subclass of A, right? And is subclass C and A. So the result should be true. Alright. So here B is a subclass of A and even C is a subclass of A. Okay. So this was an example of hierarchical inheritance. Fine. Next we have is the hybrid inheritance. It's like combination of any 2 different kind of inheritance. So we have a class A over here and class B, C, D. These are example of hierarchical inheritance, right? As all 3 of them are acquiring the properties of class A, whereas class E, it is acquiring the property of B and D, right? So it's an example of multiple inheritance. It is acquiring both the property of class B as well as D, right? Let's see example over here. Class A, x1, B pass, C pass. D is inheriting B and C, and again we are calling the object X, D object. Okay, So let's verify whether our output is 1 or not. If we get the output as 1, then it's a proof that it's a hybrid inheritance. Okay, so we have class A and we are defining x equal 1. Again, class B, which is inheriting the property of class A, pass. Again, we have class C, which is again inheriting the property of class A, pass. And we have class D, which will also acquire the property of class A. And finally, we have a class E. Okay, and class E will acquire the property of both class B as well as class D. Now, this is an example of hybrid inheritance. Till this portion. So above this portion, these three, they were an example of hierarchical inheritance, right? All three different classes were acquiring the property of class A. And here, this is an example of multiple inheritance. So below this, so multiple inheritance. And above this, from here, it's a hierarchical. If you execute it, you'll see that you will get the output as 1. Now, in order to check whether it's a hybrid inheritance or not, we'll create an object of class E. Object of class E equal E. And now let's try to access X variable, which is inside A. Let's see whether it can give or not. So it will be accessed as obe.x. If we get the output as 1, then yes, it's an example of hybrid inheritance. So yes, it's an example of hybrid inheritance. So coming back to our PPT. So this was about all the different types of inheritance in Python. Next we have is the super function. We have already come across this function, right? This function is used to call a method from a parent class. For example, class vehicle. So here two-wheeler is inheriting the property of class vehicle, right? So inside that you can see we are using super.start. So in this example, you can see we have a class vehicle and a class two-wheeler over here. This two-wheeler is acquiring all these properties. It's acquiring the property of class vehicle, right? Next, inside class two-wheeler, we are defining a function as say, and we have a super function over here like super.start. So where the start is coming from? Well, the start is from the parent class. And in order to call a method from a parent class, we are using this super function. So this was about inheritance using super function, okay? Or mainly how you can call a method from your parent class using super function. Let's move ahead. So here we have a concept of overriding versus overloading. Developers sometimes get confused with the concept of overriding and overloading. So some basic difference that you must keep in mind is like overloading is using the same method name with different parameter signature. Okay. Key point here is that return type doesn't matter. It may be same or different. And overloading may occur in the same class or subclass. On the other hand, overriding is defining a method in a subclass that is already defined in a parent class with same name, same return type, and with same parameter signature. Overriding cannot be done in same class, but you can do a overload in a same class. So let's move ahead. What is overloading a function? Let's see in detail. So we have same function with different parameter. For example, now the question arises, why to overload a function? Okay, now let me just show you an example. Suppose we have two function over here. Like my first function, it takes two parameter and returns the sum of it. Alright, returns a plus b. And I have one more function, add, same name but with different parameter a, b and c. And it returns the sum of a plus b plus c. Okay, now if I'm calling this function, like I'm passing two values in it, like 2, 4. So what do you think the output should be? How the machine will decide whether this add function is this or whether it's this? Okay, so we got an error like add missing one required positional argument, that is c. So what the machine is doing, once you are redefining the same function or method with a different set of parameter, then it is updating its memory. So for now, your add has to have 3 parameters in it. That is a, b and c. It won't return the sum of 2 variables, but it would return the sum of 3 variables. Okay, so this is the issue. Now let's see how overloading resolves this issue. So what we are doing over here is we are defining a method as add, and inside that we are passing two parameters. First is an instance variable like instance of, and next is the argument. Okay, so first what we are doing up here, we are defining a method as add. Inside that we are passing two parameters, instance of and argument. First we are checking if instance of equal to int. If the data type of the instance is int, then you are initializing result with 0. If the instance of data type is string, then you have to initialize the result with opening and closing single quotes. Fine. Next, what you are doing, you are checking for I in adds result plus equal 1. Okay, suppose, and finally return result. And when I'm calling add function, I'm passing the data type first, and I'm passing three variables like 3, 4, 5. So it will give me the integer sum of all of them. Okay, let's do this in Jupyter Notebook and let's see. So what we did up there was, first we define a function like define add, and inside that we are passing two parameters like instance of and star args, that is argument. Next, my task is to check if instance of equal type int, then I have to initialize my result with 0. If instance of equal str, then in that case my result would be initiated with this opening and closing single quotes. Fine. Then I'll define a loop like for I in entire arguments, then return result plus equal to I. Fine. Return result. The function is executed. Next, what if I want to call this function? So for calling, I'll write add. I'll specify that all the data type what you want to add is of type int. Then I'll mention 1, 2, 3. I need the sum of 1 plus 2 plus 3. Output should be 6. Yeah, we got the output as 6. Okay. Now you can even change it to 4 variable like 4. So the output will be 4 or 5, 15. Okay. One more thing what we can add up here is like if instance of double equal float, then in that case initialize my result with 0.0. Okay, it's like add float comma 1.0 comma 3.6 comma 4.90. okay, let's see what's the result. So we got the output as 9.5. Let's update this and see whether we get in double decimal or not. Yeah, we are getting it. You can even do the same task with the string. All you have to do is write str comma python comma space comma tutorial. This thing can even be written as python space. Remove the space from between. Just write comma over here and execute it. The output would be same. Got it? So this was about how you can overload a function in Python. Next is overriding a function. Well, overriding a function means that a subclass can change the functionality of a Python method in its superclass. That is, a child class can change the functionality of the parent class. Okay, that is, it can update its qualities. Let me show you with an example. So here let's define a class A. Inside A, let's define a method as check it. It has print I am inside A. This is all about class A. Next we have class B over here. I'll write same function in class B as well, like check it. But here I don't want to print the same. I want to print I am inside B. Alright, let's check what output do we get. So for that we have to create an object. Let's create an object of B. ob1 equal B and ob2 equal A. Fine. This is how you can just see what's the difference between them. So I'll just write ob1 dot check it and again ob2 dot check it. Execute it. Okay, sorry. Again the self thing. So you got the output as I am inside B and I am inside A. Fine. So let's see the example in our Jupyter notebook. It's defined two classes as class A. Class A has some function as def check it. print statement in it, like I am inside class A. And then what we'll do, we'll define another class as B. This B class will inherit the property of A. Again, we'll define one checkit inside it. This checkit will update the value with I am inside class B. We'll define a function as checkit print I am inside class B. Okay. Now let's create an object of both the classes, like ob1 equal A and ob2 equal B. Now let's access the same function from both the object, ob1.checkit and ob2.checkit. And let's see what's the output. Okay, we have missed self over here. So you got the output as I am inside class A from the object 1 and I am inside class B from object 2. So the function with same name has been updated. Okay, this is nothing but an example of overriding a function. Fine. So this was all about inheritance in Python. What is encapsulation? Well, encapsulation is basically abstraction plus data height. Now you'll ask that what is abstraction? Abstraction is showing essential feature and hiding the non-essential features from the user. For example, while writing a mail, you don't know how things are actually happening in the backend, right? So all you do there is just hit on compose mail, write your mail, and just send it. How the machine is working in the backend, you don't have any idea about it. So that is an example of abstraction. And encapsulation is abstraction plus data hiding. Okay, let's see. So what exactly is encapsulation? Encapsulation is wrapping up of data into a single unit. Another example over here, like multiple parts of car encapsulates itself together to form a single object that is car, right? It's like there are different parts in a car, right? Car has its engine, tire, wheel, piston inside the engine. So everything, like multiple parts of the car, it is joining all together to form an object known as car. Okay. So why I'm telling over here that it's abstraction plus data hiding, just see from outside what you see, it's a car, right? If you go one level inside it, you will see that it has various components in it, right? Various components like engine, tire, wheel, etc. How these things are working, that we don't have any idea about. All the things are hidden from us, right? So from outside, all you see is a car. You don't see the engine or the screws or the nuts or the car, right? So this is abstraction, that is hiding unnecessary detail from the user. Okay, and data hiding, it's like how the engine is actually working, you don't have any idea about it, right? That is data hiding. So encapsulation is what? It's just showing you the car. Okay, next, we have a convention over here. It's like a class variable that should not be directly accessed or that has to be kept variable should be prefixed with an underscore. Okay. From the example over here, you can see we have a class as encapsulation. Inside that we are defining an init function. So from this example, you can see that we have an init function over here. And inside the init function, we are defining three different variables. Self.a equal 1 to 3, self._b equal 1 to 3, and self._c equal 1 to 3. Alright, I'll just show you this using Jupyter Notebook. That will make things more clear to you. Like, let's come here, class encapsulation. So inside this, we are defining an init function, like define init and self, as it's a method, right? We will define three different variables, self.a equal 1 to 3, self._b equal 1 to 3, and self._c equals 1 to 3. Now let's create an object of it. obj1 equals encapsulation, fine, and print obj1.a comma obj1.b comma obj1.c. Execute it. So we got the error as encap has no attribute b. Okay. What if I do this? Again, we are getting the same error, right? So let's test our encapsulation over here. Let's define a class as encaps. This, what I'll do, I'll define an init function. Inside this, I'll have self.a that equals 1 to 3, self._b equal 1 to 3, and self._c equals 1 to 3. Now let's print these objects. So for that, what I'll do, I'll just create an object like obj1 equal encap. So it's the object of class encap. Print like obj1.a comma obj1._b and obj1._c. Okay, let's test the output. So we got an error like encap object has no attribute c. So why are we getting this error? Let's discuss about it. Well, we got this error because, so what's with the underscore error? Well, we'll see about it. For now, let's see what's a private method. So we have a class as car in which we are defining an init method. It has self.update software. It's _update software. So whenever you place _, it means that it's a private thing and it cannot be accessed from outside. Okay. Next we have is drive method. We are printing driving over here, and again we have defined _update software. Okay, and inside that it's updating software. So when we are making an object of the car class like red car, and we are calling redcar.drive, okay, so we can access this, no issue. But when we'll call redcar._update software, cannot access it as it is a private method, and the advantage is that it cannot be accessible from the object. But what if I want to access the private method? Then the private method can be called using redcar._car. Okay, the last line. This is how it cannot change. You cannot change a private variable underscore class name. Similarly, let's get back to our Jupyter node. And over here, what if I write obj1._encap_c? See that? We don't have any error over here. Okay, let's move ahead. Next we have is private variable. Well, again, same as private method, private variable cannot be accessed from outside. Okay, so next we have is the private variable. Again, same as private method, the private variable cannot be accessed and changed from outside because it's private. What we have here, we have like _max speed equals 0 and _name equal single quote. So we are initializing two private variables over here, max speed and name. In the constructor part or in the init method, we are defining max speed as 200 and the name as supercar. Let's move ahead. Well, the thing is, you cannot just change the value of a private variable from outside. So for that, what you need to do is you have to use a setter method. This method over here defines set max speed, self comma speed, self._max speed equals speed, and whatever speed you will, let me just show you. Like, let's define a class as ABC. Inside this we have a, let me just show you with an example. So what example we had up there was class car. We had defined two private variables up there like max speed, we have initialized it to 0, and private variable name initialized to empty string, right? Next what we'll do, we'll define our init function. Let's go init self, here self.max speed equal 200, self._max speed equal 200, and self._name that equals supercar. Fine. Now let's define another function as drive. Inside this I'll write print driving.max speed and self._max speed. Next what we'll do, we'll define a function as drive, a method actually, and inside it what we'll do, we want to print like max speed of car is self._max speed, right? So this is my class car. So this is our class. Now let's create an object for our class like obj1 equal class car. Fine. Let's call the drive function from it. obj1.drive, execute it. So you can see the output is max speed of car is 200, right? But what if I want to update its value like obj1 dot double underscore max speed equal 300. Okay, and then again what I'll do here, I'm setting the value of max speed as 300. So according to things that we have learned till now, it should be like if we are executing it, we should get the output as 300, right? It's executed, but we are getting the output as 200. So this is wrong, right? Actually, it's not wrong, since max speed is a private variable, so we cannot update it directly. Okay. So in order to update it, what we have a setter function. So you have to define another function as set. So now the question arises, how to access a private variable? So to change a value of a private variable, you have to use a setter method. Let me just show you how a setter method is used. Let's create a setter method, set max speed. It will have self parameter and the speed to it. This thing has to be inside our main class. So now I'll write self dot double underscore max speed equal speed. So this is how you can update the value. Okay, there's no other way to update it. Execute it, done. Now if you want to change the value, like ob1 dot set max speed, and inside that just pass like 300 or like 400. Okay, and then print it. So obj1. So you got the output as max speed of car is 400. Is thing clear to you? So this is how you can access a private variable. Next and the last topic in our OOPS concept is of polymorphism. Well, polymorphism is function with same name but functioning in different ways. It's like you behave differently in front of your elders and friends. A single person behaves differently at different times. Now let's see an example of polymorphism in Python. We have a class as shark. We are defining two functions over here, like swim and skeleton. Inside that we have the shark is swimming, and inside this we have shark skeleton is made of cartilage. Again we have another class as clownfish. Again we are defining same function in it, but the content of that particular method is different, right? Like inside clownfish swim function, we have the clownfish is swimming, and the skeleton method has the clownfish skeleton is made up of bone. So two different class but two same function in both of them. So let's define a class shark. Class shark has some swimming function in it, which says that shark can swim. And let's define another function as def bones. Shark has soft cartilage. Now let's define another class as class clownfish. Same function definition, swim, but for this print clownfishes can swim, and another function same, bones, print clownfishes have bone. So now we have two classes over here, right? So now that we have created the class, execute it. Now let's create object of these two classes. So let's name shark s1 equal shark, and we have c1 as clownfish. So we have these two classes over here. Now what I want to do is for fishes in s1 and c1. So we'll print fishes dot swim and print fishes dot bones. What error? Name s1 is not defined. Sorry, it's capital. Remember, Python is case sensitive, so we got the output as bound method shark dot swim of main shark object, shark dot bones of main shark object. It's a clownfish object and clownfish dot bones. So this was about the polymorphism in Python. We have to do a polymorphism with a function. So here what we are doing, we are defining another function as in the Pacific, okay, and we are giving a parameter as fish, and inside the function we are calling the swim function. So it's like I'm defining another function in the ocean, okay, fish, and inside this fish dot swim, S1, and in the ocean. So you got the output as shark can swim and clownfishes can swim. So here in the ocean, in this function, we are just calling one function over here, right? Swim, and the program itself is deciding which swim it has to take, right? If we are passing S1 to it, then it is coming from the shark class, and if we are passing C1 to it, then it's coming from the clownfish class.
So guys, here is a question for you. What type of inheritance is illustrated in following piece of code? Options are option A, multi-level inheritance, option B, single level inheritance, option C, multiple inheritance, option D, hierarchical inheritance. Please comment down your answer in the comment section below to check if you have answered correctly.
A quick info guys, in case if you want to become a Python developer engineer, then in that case you can check our Python certification course. Intellipaat is giving a end-to-end training on Python. For more information on this course, kindly go through the link in the description. This brings us to the end of the video. Hope this video was informative. In case if you guys have any query, please put down in the comment box. We will reach you out as soon as possible. Thank you.